What we don't know is the yield to maturity. Okay. Face value 100,000. Price 104.352. So it's 104.352. Coupon rate is 3.6. Coupons are paid annually, so that's one. And 16 years to maturity. This template automatically highlights your unknown anyway, so you don't even have to look for it. Your unknown becomes pink background, so you just read off the answer from there. Anything unclear on how I did this? How about you, Zaylen? Good. Let's see. These are all pretty much the same, so I'm not going to spend too much time on it. Let's do some, these are some basic questions. Let's do some intermediate ones. Okay, let me copy these. Okay. This is basically mostly about interest rate risk of different kind of bonds. Okay, bond X is a premium bond, which means coupon rates is higher than yield to maturity. Pays a coupon of 7.1%, is the YTM of 6.4%, 13 years to maturity. Bond Y is the discount bond, blah, 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 blah. What is the price of each bond today? We can easily do that using our template. Since I'm calculating value, that's red light. Let's see. Coupon rate 7.1. Yield to maturity 6.4. Semi-annual, so coupon frequency is 2. And 13 years to maturity. So we pretty much read it off of there. So this is on X, because it's going to ask some related questions. So let's copy that price. And come on, paste the value. Bond Y, let me see. Same coupon rates. No, same maturity. But this time coupon rate is 6.4, YTM is what 7.1. Everything else is pretty much the same. So okay, copy, paste the values. Okay, these are the prices of the base scenario. It says what is the price of each bond today? If the interest rates remain unchanged, what do you expect the price of these bonds to be 1 year from now? And 3 years, blah, 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 blah. Okay. I'm going to do the bond Y first. Okay. 1 year from now, the only thing that's changed is the years to maturity, right? So how many years will I have left on this bond 1 year from now? 12. So I'm going to enter it. What happened to the price? Did it go up or down? This was the basic. It went up. So next is how about in 3 years? In 3 years, this will have 10 years left to maturity. Price is going to go up again. In 8 years, it will have 5 up again. 12 years, 1 up again. Obviously, in 13 years, the bond is going to mature, which means it's just going to pay the face value. But what's going on here is if yield to maturity does not change, as the bond approaches its maturity, price of a discount bond, which is bond Y, okay, keeps increasing. Essentially, the discount is less and less. If we did the same thing for the premium bond, in 12 years, in 1 year from now, the value is, this is the original value. 1 year from now, the bond value is going to go down. 3 years from now, it's going to go down even more. Okay. At 8 years from now, even more. 12 years from now. On the other hand, if the bond is a premium bond to begin with, if the yield to maturity does not change, it still remains the premium bond, but the premium amount keeps decreasing. Eventually, we're going to go down all the way down to face value. So discount bond values go up as time passes if the yield to maturity does not change. Premium bond values go down as time passes, provided the yield to maturity does not change. And this is basically what's going on here. If you graphed it, you would have gotten the graph. Since we're not going to do any graphing in the exam, I'm not going to bother with it. What's going on here is for a premium bond, uh, coupon rate is basically higher than the discount rate or the yield to maturity. Or for a discount bond, coupon rate is lower than the yield to maturity. So that discount is a compensation for that. I mean, if yield to maturity is 8% and coupon is 4, my required rate of return is 8, but the bond is only giving me 4, right? So every year I'm getting less compensation that I want. So why would I pay the full face value for that? I demand a discount. But as the bond gets closer and closer to its maturity, the amount of compensation I need is less. Originally, I had to be compensated for 13 years of getting paid less. Now, when there is 5 years left, I need to be compensated only for 5 years. That's why it just converges to the face value. Let's do this interest rate risk one. Both Bond Sam and Bond Dave have 6.7% coupons, make semi-annual payments, are priced at par value, which means face value is equal to the uh, price, or coupon rate is equal to the discount rate. Bond Sam has 3 years to maturity, whereas Bond Dave has 20 years to maturity. If interest rates suddenly rise by 2%, what is the percentage change in the price of Bond Sam and Bond Dave? So let's do this. Originally, coupon rate and bond yield to maturity are the same. So 6.7 semi-annual. Let's think about the bonds. Sam. In fact, we know the price is 1,000. But if yield to maturity goes up by 2 percentage points, we're going to enter 8.7, right? And independent of the bond, when the yield to maturity goes up, price of the bond will always go down. And percentage change for this was Sam, I think. 948.17 is the new price. It was 1,000 minus 1. Let's make it percent. So the value of this 3-year bond is going to go down by 5.18%. Now let's do the same thing for bond Dave, which has 20 years maturity. 811.98 divided by 1,000 minus 1. As you can see, this is a much larger decline. So the value of the 20-year bonds would go down almost 19%. On the other hand, value of the 3-year bond would go down slightly over 5%. And the reason for this is this bond Dave has a longer maturity. Okay. Everything else being the same, the bonds that have longer maturity will lose more of their value as yield to maturity goes up, which means it is riskier. On the other hand, if the rates were suddenly fall by 2%, the reverse is going to happen. 3-year bond is going to gain in value, but percentage change is going to be much higher for the 20-year bond. So in general, this basically tells us that longer is the maturity,